First, thank you very much for the ESA and the professors to organize this seminar series. I'm very honored to present my results in front of everyone today. And I'm also particularly thankful for Professor Sarah Garcia to take the discussion for me. This is a joint project with Guangying Chen, another PhD student in the marketing program of All-in Business School in Washington University. All right, so let me start. Communication is a mutual process, but oftentimes it is the sender who plays a more active role by choosing which message to send. And it is also possible for the sender to use a vague message to mislead the receiver. And at the same time, it is equally possible for the sender to use a more blatant lie to mislead the receiver in a more effective manner. So a natural question is why and when one should use a vague message over a blatant lie. There are many applications to this problem. For instance, a disclosure game, a public good provision game. And unfortunately, this is very relevant nowadays. Like imagine a politician is asked a question about the state of the world, and the politician could choose to be evasive by using a vague message, or the politician could use a blatant lie to mislead them in a particular direction. And when asking these questions, we have to consider both the strategic and the behavior aspects of vague communication. The reason is, a message not only updates the belief about the state of the world, but it also changes the receiver's belief about how honest the sender is. So if the sender cares about the reputation, then this should impact her choice of strategies. And at the same time, the sender might have different attitude toward different methods or different degree of misleading behavior. The sender may not feel uncomfortable of making a blatant lie and such. So how do we approach this problem? Is that we present a model of information transmission with vague messages and line cost. And then we test the theoretical predictions through an online experiment. The main results that we find is that the use of vague messages arises endogenously from our theoretical predictions. And then we actually see that the majority of people use vague message when they're allowed to do so. And many people prefer to be vague and truthful. We have to elaborate a little bit on this later. And some people still do not use vague messages even when they lose potential monetary gain by doing so. And how do we fit this into the literature? Well, there are many papers that I should give credit for, but structurally, in a broad sense, this is a subset of Signaling Game by Crowfold and Sobel. One thing here is that because we want to focus on the role of the sender, we minimize the role of the receiver using this experiment called rolling a die. And for those who are not familiar with the literature, let me give you a quick intuition about that setup. So in a rolling a die experiment so we try to simplify the signaling game into a single person decision problem of the sender. The sender privately observes a random number, i.e. by rolling a die, and the receiver, the experimenter, does not observe that draw. For instance, in our example, the sender says, roll a die and sees the number 3. And then the sender reports the number to the experimenter, and the experimenter pays proportionally to the report. In our example, the sender could report 3 and receive $3. But what can also happen is that the sender chooses to lie and report a much higher number, say 6, and receive $6 for it. So the discrepancy between the number that he or she could have gotten and the number he or she actually reported should measure this aversion toward lying, or at least the aversion toward this profit maximizing behavior. So a one-line summary of our research question is, what happened if we let the sender to use a more complicated kind of message? Say, instead of simply saying my number is 3 or 6, we let the sender to say a vague message. My number is somewhere between 3, 4, 5, and 6. Going back to the literature, this rolling a die experiment has been very successful, and there have been many experiments that followed this design. Ebeler, Nocenzo, and Professor Raymond here has summarized, I believe it's 72 of them, summarized these many experiments, and they concluded that indeed people, on average, their average report is substantially below the maximum possible number, but is also higher than the expected number. For instance, by rolling a die, the expected number should be 3.5, but people on average report something higher than that, but less than 6. And two of the most influential, or I should say the closest paper that I follow among those 72 papers is by Gnizzi, Keh-Kuan, and Sobel, and Kalmetsky and Slivka. These both papers assume that, that people care about both being honest and also being seen as honest. So we inherit their model structure and then we extend it by generalizing the message space to include these vague messages. So let me give you a quick overview of the model. I will try not to talk about too much of the technical details here. We have a population of agents and one audience, and each individual agent observes the state of the word I, like by rolling a die or drawing a card out of an envelope. And this draw is uniform over numbers 1 to 10, and it is IID across the individuals. The agents then sends a message J after observing I. This message J is a non-empty subset of omega, which is different from the previous experiments. In the past, it was only a single element of the omega. We allow them to be a subset of omega. A message J is truthful if this J contains the true state I and is a lie otherwise. And we call a message is precise if it's a singleton and vague otherwise. And the agent receives the monetary payoff proportional to their message. For instance, if this agent draws 5 and reports 8, 9, 10, then the experimental software randomly draws one number out of the report 8, 9, 10, and the agent has the equal probability of receiving $8 or $9 or $10. And in addition to the monetary payoff, if the message J does not contain the true state I, then this person should feel the internal guilt or some psychological cost for it. And we assume that this is an indicator function. And also lastly, the agent is a rational Bayesian who updates the posterior belief based on the report J and updates updates the belief of how honest the sender is, and we normalize it with gamma. This is a one-shot game and there is no repeated interaction. Our design, the main treatment effect is between this precise and vague communication. We did this online. We invite students to Zoom meetings for instructions, and then we used Qualtrics for the main experiment. Subjects first observe a random number between 1 to 10 on their web browser, and then they report the number to the experimenter by clicking boxes on the screen. And we asked them twice, so we call them stages. And in the first kind, the precise stage, they see a number and then they can select only one box at a time. In a vague stage, they see a number and then they can select multiple boxes at a time. And we randomize the order of these two stages. Here's a screenshot of the vague stage. So we asked them, what number did you see? You may select a set of numbers. You may click multiple numbers on this screen. And then we're going to interpret it as a statement that the number you saw is one of the numbers you selected on the screen. And on the other hand, in the precise stage, we asked them, what number did you see? Please report us by clicking a number on this screen. We also add another layer or another dimension of the variation in terms of the anonymity of agents. So this is in terms of our model, this is to remove the effect of the reputational concern. And how did we achieve that? In the identifiable treatment, we asked them, okay, there's two stages, but we're doing so by asking their real name and their student ID, and we ask them to keep their video on during the experiment. So the idea here is that we can have a clear mapping between your true identity and your responses. On the other hand, in the anonymous treatment, we ask them to use a screen name instead of their actual name, and we don't collect their student ID or any other personal information. We ask them to keep their video off. So the experimenter, from the experiment's point of view, there is no clear mapping between their actual identity and their responses. And we take the advantage of this anonymous environment to add the observability of the true state, which is similar to what Professor Raymond had done in the Econometrica paper, is that because now that this experiment is anonymous, we don't have to worry so much about their concern of being seen as a liar. So we generate the random number inside the software and then we collect it, we record it so that we can make a direct comparison whether this person had lied or not. All right, moving on. Let me give you a quick summary of the data. So we have recruited 69 people from Washington University, and then we ran 4 anonymous sessions and 7 identifiable sessions with the average size of 8.3 and 5.1 participants in each session. We collected 36 and 33 people respectively, each session lasted approximately 30 minutes. Let me jump to the results right away. We probably don't have time for the whole theory, but I'll try to drop in the intuition as much as possible. So the first hypothesis that we start from our baseline identifiable and precise environment, which corresponds to the existing literature. And then we make a comparison by moving to the anonymous setting. And our theory says by making this environment anonymous, we are removing their reputational concern. Therefore, people should feel more free to lie, and therefore they should report higher on average. And we find that from our data that in anonymous, they report slightly higher, but this difference is not very significant. It's possible because our sample size is small yet, but still this is consistent with the prediction. Now, moving to anonymous and vague environment becomes more interesting. And if our assumption of that this internal cost happens only if this message is a lie, meaning that this message J does not contain the true state I, then an immediate implication is that if you're a truth teller, as long as you're including some truth in your message, feel free to increase your expected payoff. And the optimal way of doing that is to use this particular type of message, which is a union of your true state and some kind of ending sequence. And the threshold of X star, you can calculate it by solving the optimization problem. And our data says 45% of people, 45% of the truth teller actually use this optimal form. And we also find almost 20% of the truth teller use a pair of true observation I and maximum number 10. We interpret it as, okay, they kind of understand that they're still telling the truth, so they have the freedom to increase their expected payoff, but they don't know how to exactly calculate the threshold, so they just use 10. Anyway, in any case, we see almost 2/3 of the population of the truth tellers try to increase their expected payoff. Still, 1/3 of the population of the truth tellers still use a very precise and honest message. And these two are the corollaries of the first result, that no message should contain a number less than the true observation. We find only one person doing that. We understand that's probably a mistake. And no precise message except 10 is truthful. And we indeed find that all precise messages except 10 were a lie. Okay, next result. Now that we have established some level of these anonymous precise and anonymous vague treatment, we can make a comparison between them. Our theory says more agents should lie when the communication is restricted to the precise messages. And indeed, we find that from our data. 12 people lied when the message space was restricted to the precise case. Only 6 people lied when we relaxed that restriction. Also, an agent who is truthful in the precise case should also remain truthful in the vague case, conditional on seeing the same observation. And we actually found a stronger case that all participants who were truthful in the precise case, regardless of their true state in the vague state, they still remain truthful. This is also a very interesting result, that there should be a subgroup agents, depending on their type, which is explained more detail in the paper, in the precise case can switch to truth telling in the vague case, conditional on the same observation. The intuition behind this is that now that we're still off the reputational concern. Now that we give them an option to remain truthful and then increase their expected payoff. So if they were lying in the precise case because of the constraint optimization, they don't have the freedom of much of the richer message space. If they were lying to increase their expected payoff, they should not do that when we give them the option to remain truthful and increase their expected payoff. And indeed, we found that 6 out of 12 liars in the precise case switched to truthful and vague messages in the vague when we allow them to do so. And what's more encouraging for me is that these 6 people, they reported 10 in the precise case. They were definitely going for increasing their expected payoff. And they had the same option in this vague treatment, but they did not do so because their expected monetary payoff by using the vague message is lower than 10. So this is very encouraging for me to interpret this data. And also we find that the agents report on average higher. This is just a corollary of the first result. Now that we have established this analysis of the vague environment, we can compare these two identifiable and vague environment and anonymous and vague environment. We find that in both cases, people use vague messages as the theory predicted. And what's more interesting is that in the identifiable and vague environment, almost 70% of people use the vague message. On the other hand, in the anonymous and vague environment, only 55% of people use the vague message. And also, conditional on using a vague message, the size of the vague message, meaning the number of numbers that they're using in their message, is greater in the identifiable case. On average, when they're using a vague message, they'll use 3.7 numbers in their message. And then in the anonymous case, they will use 3 numbers in their message. And we try to interpret it in this way. So the difference between this identifiable and vague environment and the anonymous and vague environment is that there is this reputational concern. And for instance, if your true state is 1, then your optimal vague message, as we defined earlier, is 1, 8, 9, 10. But in this, that's fine in the anonymous environment because you don't care about your reputation. But in the identifiable environment, this is actually very obvious that you saw some really low number like 1, and you're trying to increase your expected payoff. So in form, the message is vague, but the content of the message is actually not vague. This is also a very interesting point, but I don't have time to go into it. But the idea here is because now people care more about their reputation in the identifiable environment, they try to use the vague messages more often, and especially when they use a vague message, they try to have a higher degree of vagueness in their messages. All right. Lastly, we also we compare the identifiable and anonymous environment using the vague messages. We find that this supports our theoretical prediction that people should report higher on average in the anonymous environment. Again, this is still inconclusive with a high p-value, but is consistent with the theoretical prediction. And lastly, comparing the precise and vague treatments in the identifiable environment, that we find that agents report much higher when they are allowed to use vague messages. Couple of concluding remarks. Okay, a quick summary that we predict that people should use vague messages endogenously from the lying aversion, and our data confirms that. Overall, participants reported much higher on average when they are allowed to use the vague messages. And this suggests that some portion of the observed aversion for monetary payoff maximization in previous experiments using only precise messages can actually be decomposed into smaller parts. There can be the signaling component of this lying aversion that we have seen before. And then our paper suggests a way to decompose them into smaller components. And also the vagueness of a message, if our assumption on the indicator function on that internal cost of lying, then the vagueness of message should only cost the reputation and does not affect the internal cost of lying. And our data partially supports this assumption using the comparison between the anonymous and identifiable environment using vague communication. And we find this somewhat analogous to the warm glow type of giving. So as long as they can signal their goodwill by including some truth in their message, it seems like there is no extra cost necessary, and they exhibit no hesitation in increasing their expected payoff. And the existence of the precise truth tellers, 1/3 of people who were like precise and truthful in the anonymous environment, suggests that we should consider other aspects of truth telling. For instance, it's possible they care for the concern for the accuracy of their messages on top of being honest. And also they also care about, it's possible they care about the self-image of their good intention as well, which relates to our earlier presentations today. So I find them all very interesting, and some couple of things that we're still working on is that we try to increase the sample size to do the likelihood estimation of the lying probability in the identified environments using closed form solution. And there is a possible concern for a metagame. Are these precise and the vague treatments independent? And we can run a logic regression to say that the probability of lying in one treatment is independent of the other, and so on. Okay, and lastly, the equilibrium part, that's more theoretical concern, and we can talk about that later. All right, thank you very much. I try to rush through everything, and I hope you enjoyed the talk. And now I'm very excited to hear Professor Sarah Garcia's comment on the paper. Thanks.